Residential HVAC parts and how they work. I've got a table full of parts that you'll find on residential HVAC equipment if you're an HVAC technician. If you're watching this video and you want to be a technician or you're a new HVAC technician, this is going to be a great overview of basics on parts that you'll find and how they work. Before we start today's video, hit the like button, subscribe, and hit that bell, ding, so you know what I'm doing. Definitely leave me a question in the comments. I love questions. They lead to content. If you don't have a question, tell me who you are and tell me where you're from. I want to know all my viewers. If you want help with your project, if you want tech support, you just want to contact me, great, good. I want to help you. So click the join button, become a member. Let me know in the comments down below. Say, I joined. I'm going to say, thank you. You're awesome. I'm going to give you my email, and I've got some guides I can send you as well. If you want to learn more about working on mini splits, if you want all the member only videos that I've been putting together, like how to install ductwork, how to size your ductwork, how to size equipment. I've got a bunch of videos and also pricing. So how to price equipment, price parts. You'll gain access to all that. I'm Tad. You're watching HVAC Tips for Technicians. Let's get started. So I've got a bunch of parts here, and I'm going to go over all these parts in today's video, so you should have a really good idea of what parts you're going to be working with in the field. And I'm going to explain to you how these parts operate and in what cases do they go bad and what you will find, so that you will have a leg up when you start going into the field as a technician to start working. So from left to right, let's go over filter dryers first. A filter dryer is a filter that is installed in the refrigeration system. This one's got a 3/8 connection, so 3/8 copper would go to this, and this is a single direction flow filter dryer. So the flow of the refrigerant will only go in one direction, so you would not install this on a heat pump, because of course we would install a biflow filter dryer for a heat pump. So this is a biflow. How do we know? We have an arrow that points both directions. We've still got the 3/8 connections on each side for our copper, but this right here would be installed on a heat pump, and this would be installed on a split air conditioner, so just straight AC. And this is a way for you to ensure that your components like your compressor and your metering device don't have air or non-condensables in them or just debris. This right here is just a filter. So you definitely need to make sure that anytime you change a compressor, you change a filter dryer. Anytime you change anything in the system, you always go back with a new filter dryer. So that brings me to the next part. This was filter dryer. This is a reversing valve, and the reversing valve switches the flow of the refrigerant in the system, and it uses this coil to energize. So this coil, usually you have 24 volt coils, but I've seen coils that are 240 volt. So this right here would slide on to that, and then once the power is inputted or energized right here to this coil, then that would activate this valve. And usually, different manufacturers have energizing either in heating or in cooling, and you would be using O or B for energizing the reversing valve. Rheem and Rudd energize in B, and then most other brands like York, Trane, American Standard, Carrier, they energize in O, so energize the valve in cooling. So you'll learn more about that, but this is a reversing valve. It's not a very easy part to change. Depends on how big the valve is and how easy you can get to it. And this part doesn't normally go bad, but I have seen some go bad and had to replace some. This right here is a liquid line solenoid, and usually this is on refrigeration equipment. And I've also seen this on some residential systems, but not very many. Usually this has a coil just like this, and it energizes this valve, and usually this doesn't open. It stays closed until the compressor is energized. And this is a great way for you to ensure that the refrigerant stays in one section of the equipment, and that is normally the indoor coil. And then when the compressor energizes, then this liquid line solenoid would open up. It's got 3/8 connections, looks like. Actually, that looks like 1/2 inch connections on this one. So this right here is a TXV. This is a thermostatic expansion valve. It's got a bulb. It's a mechanical device, and what it does is it meters the refrigerant inside of the system. And anytime you take this bulb off of the line to where the
temperature of the refrigerant is no longer affecting it, that means that and if you put your hand on it, it's going to warm it up and it should open this valve. So when this stays on the line, refrigerant's flowing through, it's monitoring that that temperature, and the colder this gets, the more this valve will close down. So this is thermostatic expansion valve. It's a metering device, and it's standard on most equipment now, especially when you have 14 SEER and higher, because that's how you gain some efficiency, is with this type of metering device. And whenever they go bad, I've got a video on it, you should check it out, but whenever they go bad, lots of things can happen. The suction pressure can fall to 0, and when you try to add refrigerant, this thing is stuck closed, so you can't add refrigerant. Head pressure goes up 500-600, and it doesn't matter if you recover refrigerant out of the unit, their head pressure is still super high. So check out my video on HVAC tips for technicians. I got a video on TXVs. All right, so where are we going to go next? I think we should talk about relays. If you want to know more about relays, how to check them, how to use your meter, check out my playlist. I got a video on transformers and relays and how they work. Let's talk from left to right. This is a transformer, and you can see it says 240 volt and common, and this is where our line voltage would come in, and this is where our low voltage would go out. And this transformer basically steps down the voltage so that we can, from line voltage, now we can have control voltage. So we can control things like these relays or this thermostat, because this is a remote control. This is a control that works off control voltage, and it's used to operate the equipment, to either change from heat, cool to off, and that's what thermostat does. All right, so our first relay here is a sequencer. Sequencer is typically used to control heat strips in a straight electric furnace or a heat pump's backup heat, and these typically go bad, especially in trailers. Sometimes you'll see them burnt, and sometimes when you take them out, this piece right here will just come right up off of this bottom part where the coil is. This is the coil, this is where your low voltage goes, and this is where your high voltage goes right here, okay? That's a sequencer. And the difference between these three relays right here and this contactor is, this contactor is used to control bigger loads that have more current, and typically you'll see it control more than 20, 30 amps, sometimes 40, 50 amps, and then this right here is only rated for probably 20 amps or so. This right here is a 9340 relay, and you've got a set of normally open and normally closed contacts, and then you've got your coil right here, and this is your coil. This is where your low voltage goes, and this is where your high voltage would go. Same thing for this. You've got a coil, and then you've got contacts. This is a relay. So this contactor here, it's 24 volt coil. The coil's right here on the sides, and then you'd have line voltage coming in and load voltage coming out. Line and load, line and load. Load goes to the load, line comes from your source of your power into your contactor. All right, what else? What else? So let's move on over here. This is pressure switches. We have got a low pressure switch, we've got a high pressure switch, and usually these pressure switches are closed, and this right here would open on a rise, and this right here would open on a fall. So anytime your pressure drops below 25 or probably 0, this low pressure switch would open. It's a safety, and it is in line with the coil of this contactor. So anytime these pressure switches open because either the pressure is way too high or the pressure is way too low, then it would de-energize the coil of this contactor, and therefore it would turn the compressor off, and usually the outdoor fan motor. That way you're not running with no pressure or running with too much pressure. So those are pressure switches. All right, these are capacitors. This has a dielectric fluid and a piece of metal inside, basically, and it stores static electricity and it accumulates electricity so it can help motors run. This is a run capacitor, and this is a start capacitor. This start capacitor is rated for way more microfarads than that run capacitor. See, 324 microfarads. Typically, this is used to start the compressor, and this is used to run the compressor. So this right here is rated for 20 microfarads. This was rated for 300. So the difference is this is used to start, this is used to run. All right, now let's move forward. This is a burner, and this burner has a little track, and that flame travels from this area over here and then through the track to the next burner that's right beside it. And this is where the orifice will set, and the flame will be pulled through here into the heat exchanger. This is a burner, and this is typically a burner for an American Standard unit. And you'll want to clean this right here, because once the flame stops traveling across and you see 2 or 3 burners have flames, but then the other burner doesn't, you need to get some sandpaper. You need to get a steel brush to clean this off. That way the flame can travel, okay? All right, hot surface igniter. This is a hot surface igniter. This is either 80 volts or 120 volts goes to this plug, and then this glows. And this right here is used to start, well, the gas valve opens on a furnace, and this right here is what provides the ignition source, okay? So let's talk about, that was a hot surface igniter. This is a spark igniter, and this is a pilot tube assembly. And this is where the pilot tube would come in, and then you've got an orifice right here. See that orifice? You can barely see it, but it's right there. I'm pointing to it right there in this. And this is where the gas would flow in. And then we have a spark igniter. You see that spark igniter? It sparks off of this, okay? And then we've got a flame sensor over here. You see that white wire going to that flame sensor? Once it sparks and the pilot tube is flowing gas from the gas valve, from the pilot valve into this tube, out here, it sparks, then it ignites, and then the flame sensor sends a signal back to the board, letting the board know, hey, we have flame. This is where the, this is ignition control board, and this is where that spark would come from. This right here is the spark igniter. So we also have a wire that comes back to this board. This is the ignition control board, all right? This right here you'll find in a furnace, and this controls the ignition, and then the safeties and all that. And then this right here is a defrost board. Okay, this defrost board usually have time and temperature. Some have sensors like this, an ambient sensor and a coil sensor, and usually defrost depends on the delta T between these two sensors and then time. Or you have a defrost switch, okay? This is a switch right here that's mounted on the outdoor coil, and when this switch opens and closes, then that changes the defrost. So this board has a relay that goes to the outdoor fan, and during defrost, whenever this switch opens and closes, and then that engages this board to go ahead and open the relay for the fan, it shuts the fan off, and then it energizes the cooling so that the compressor is running and cooling the reversing valve switches, and sends hot gas to the outdoor coil. So that's kind of a little bit of an overview over the defrost board and then this defrost switch. All right, gas valve. Gas valve opens and closes, sends gas to the manifold and the orifices, and then through these burners here. And this right here has a 24-volt valve. So anytime you energize, you got 2 wires common, and then that call for the gas valve, it's going to open. It opens the diaphragm and sends gas in through the valve and then out the other side. Usually you can measure the gas because there is an inlet and an outlet screw, and usually it says in and out, and you're able to use a manometer. If you don't know how, check out my playlist. I got a video on that. This right here is a pressure switch, and usually the pressure switch has a tube, and that tube goes to the inducer motor assembly. And you can see there are 2 wires that go to this, and 24 volts is provided, and normally this switch is open. And whenever the vacuum is pulled on the switch, more than 0.18 water column, then this will close. And I will show you how this closes and what it sounds like. Check this out. You hear that? You hear that closing? Now, it's not actually good for the switch, so I don't recommend you do that. But these are very easy to tell if they are working or not. You would take a meter, and you can check from your common or your ground in your equipment to each side to see if there's 24 volts going through this. Either that, or you could just take And when the unit's running, you can take both wires off and then put your meter on ohms and then go across this and see if you have continuity. If you do, the switch is closed. All right, now more parts in gas furnaces. This is a limit switch, okay, and it looks like 180 and 30. That's the temperature. I don't think that's really the temperature though. And this is a limit switch, okay, and these are found in furnaces. This is an adjustable limit switch, so it goes from 175 up to 215. And it says right here, it's a snap disc limit control. What does that mean? Well, when it gets hot, it pops this disc on the bottom, okay? And usually that will open this up. So you'll no longer have a circuit through this limit switch. It'll be open, and that will usually shut down the ignition. And sometimes it makes your blower run so that your limit problem or your hot situation where it's too hot, that ends because it cools it down. All right, so let's look at this. It says open 200, thermal limit, close 170. So right here, this is mounted in the area where the heat exchanger is, and when it gets hot, of course, this right here will open the circuit. So then, of course, the unit will no longer be heating, and then, of course, it will probably cause the indoor fan to run so that it cools it down. So this is a good safety. This is also a safety. This is a safety for the inducer. This is a safety for your furnace. All right, let's keep going. This right here is your thermocouple, and this is on standing pilot systems, and this right here is in front of the flame. Let's see, just like this right here. See this flame sensor? That's basically what this thermocouple is, and it would be right there, and whenever your pilot would light, then this right here senses the flame and sends a signal back to the gas valve, letting the gas valve know that, hey, we have a signal, we have flame presence, and whenever there is no flame presence, then this millivolt signal would not be sent back to the board, and it would shut the unit off. So this is like a safety right here. Let's see, this is a condensate pump. Condensate pump has a normally closed, I'm pretty sure, switch. And whenever whenever it gets too high, then that will open a circuit, and you can tie this in with your thermostat so that it shuts the power down, and that way you don't have any water in your floor. Condensate pump has a motor, and that motor, whatever the float engages inside this reservoir, then that's when it will energize the pump, and then it'll send water through this little barb fitting here, and this fits a 3/8 tube. So if you want to know what a 3/8 tube looks like, this is some 3/8 tubing right here. You may need this. There are 120 volt condensate pumps like this one, 120 volt. And then there are 230 volt condensate pumps. I don't know if we've got one or not. Nope, that's 115. All right, this is an inducer motor. It's got a Hall effect sensor on it, so it doesn't use a pressure switch. And this is for Carrier. Carrier, I think, is the only brand that has these Hall effect sensors. Whenever the motor runs, this sends a signal back to the board, letting it know the inducer motor has proven that it is working. So I wanted to show you that because not many people know what this is, but this is a Carrier inducer motor. This right here is some burners. If you want to know about motors, I have a video that specifically goes over motors and the different types of motors and brackets and how to get a blade off of a motor. You may need that information. Oh, hard start kits. If you want to know about hard start kits, I have a video on how to install a hard start kit, why we use it. So this is a great way for you to make sure, well, to get your compressor running back again if you don't have a hard start kit on it, and also to keep your lights from dimming in the home. So that's a good thing. What else? Compressor harness. This is a compressor plug. This typically goes to a compressor. It's got 3 wires, common, start, and run. There's another pilot tube assembly. Here's a double sequencer. You'll find that on trailers. What else do we got here? See if I can find anything else that I can include in this video that would help you. I think that's about it, guys. I want to do a little video and give you as much knowledge as I can about these parts. Hopefully it wasn't boring for you.
Sometimes it can be a little monotonous when I'm just going over stuff I've gone over, but I think it'll help somebody. I think there's somebody out there that enjoyed this information and learned a lot. So if you did, if you're one of those people, comment below, let me know what you learned and tell me thank you. That keeps me moving, keeps me going, keeps me knowing that these videos are not a waste of my time or your time. So thank you so much for watching. You've been watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.